In this lesson, we'll take an introductory look at work questions. So far, we've looked at motion questions. In motion questions, you'll recall that we were concerned with the relationship between distance and time. Work questions are very similar, except that instead of looking at the relationship between distance and time, we'll be looking at the relationship between work and time. Now, what do we mean by work? Work refers to either units produced or jobs done. So units produced would, for example, be number of pencils produced. Jobs done would, for example, be number of lawns mowed or number of pools filled. In all of these cases, we're dealing with work, and we would input these quantities into the appropriate formulas. So, what are the formulas? Well, notice the formulas for work are very similar to the formulas for motion. The fundamental difference is that instead of putting distance into the various components of the formula, we'll be putting work in. The actual arithmetic and algebra will still be very similar, except we'll be solving for output instead of distance. Now let's look at how to apply these formulas. So let's first look at rate. We know in motion questions, the formula is rate equals distance divided by time. For work questions, the formula is rate equals work divided by time. So if we want to solve for distance, let's say we're told that Bob traveled for 300 miles at a rate, for a time of 5 hours, and we wanted to determine his rate. We'll take his total distance of 300 miles, divide by his total time of 5 hours, and arrive at a rate of 60 miles per hour. Now, let's say we're told that Bob produces 300 pencils, so he has a work of 300 pencils, and that he works for 5 hours. His rate of production is going to be his total work of 300 pencils divided by the time that he worked of 5 hours to arrive at a rate of production of 60 pencils per hour. Now, let's look at the formula for distance versus the formula for work. Let's say Bob goes at a rate of 60 miles per hour and that he travels for 5 hours. His total distance will be his rate of 60 miles per hour times his time of 5 hours, which comes out to 300 miles. Now, let's say Bob produces 60 pencils per hour and that he works for 5 hours. To get his total work, or in other words, the total number of pencils produced, we're going to take his rate of 60 pencils per hour, multiply by the time of 5 hours, and arrive at an output of 300 pencils. Finally, if we look at time, let's say Bob travels for 300 miles at a rate of 50 miles per hour. To determine his time, we'll take the total distance he traveled and divide by his rate. So 300 miles divided by the rate of 50 miles per hour will give us time traveled of 6 hours. Similarly, let's say that Bob produced 300 pencils and that his rate of production was 50 pencils per hour. To determine the time he spent producing these pencils, we'll take his total production of 300 pencils divided by his rate of production, which is 50 pencils per hour, and arrive at a time of production of 6 hours. Now, let's look at a sample work question. Working at a constant rate, a machine produces 30 pencils in 4 hours. At this rate, how many pencils does the machine produce in 20 hours? Now, notice we're concerned with determining the machine's output, so we'll use the formula rate times time equals work. Now, the output we're looking for is specifically an output after the machine has worked for 20 hours. So we can input 20 for time into the formula and arrive at the equation rate times 20 equals work. So to determine the machine's total work, we need to determine the machine's rate. To determine the machine's rate, we'll use the formula rate equals work divided by time. Okay, so to fill this in, well, we know the machine produces 30 pencils, so we could put its work as 30 pencils. And we know that it does this in 4 hours, so we can input 4 for its time. The rate of the machine is therefore 30 pencils divided by 4 hours. Now that we know the machine's rate, we can substitute this rate back into the work formula and arrive at 30 over 4 times 20 equals 150. Now, we're going to move on to combined rates. So combined rates are one of the trickier topics in rate questions. These give a lot of students difficulty because here, instead of looking at one person doing a job or one machine doing a job, you're going to be looking at people or machines working together. So if we work through this question, so we're asked how many hours it will take Bob and Jack to mow half of the lawn. Now, since we're trying to solve for time, we'll use the formula time equals work divided by rate. Now, notice the desired work here is half of the lawn. So this is half of a job that we want to complete. So the work in the formula is going to be 1/2, which will give us the equation time equals 1/2 divided by rate. So to determine the total time that Bob and Jack work together, we need to determine their rate. Now their rate here is their rate when they work together. So really what we're solving for is what's called their combined rate. Now this is very important. To determine their combined rate, we're going to take the sum of their individual rates. In other words, take Bob's rate, add Jack's rate, and that'll give us their combined rate. Okay, so now that we're trying to solve for the combined rate, let's determine these individual rates. To do so, we'll use a formula, rate equals work divided by time. Now let's start with Bob. We know that Bob will mow one lawn in 3 hours. So his rate is 1/3 of a lawn per hour. Now if we go to Jack, we know Jack will mow one lawn in 5 hours. So his rate is 1/5 of a lawn per hour. Now to get their combined rates, we will add up these rates. So we'll add up 1/3 plus 1/5, get a common denominator of 15, and we get 5/15 plus 3/15, and that will equal 8/15. So their combined rate is 8/15. Now we'll take this combined rate and substitute it back in for the rate in the time formula and arrive at the equation time equals 1/2 divided by 8/15. Multiply by the reciprocal, time equals 1/2 times 15/8. Simplify, and time equals 15/16 of an hour. Now let's look at another example of a combined rate question. Now, notice in this question, we do not have the individual rates of the pumps. Whereas in the previous question, we did have the individual rates, right? We were told Bob and Jack's individual rates and wanted to get a combined rate. Here, since we don't know their individual rates, we're going to have to assign variables. So we'll let X equal the rate of pump X, and we'll let Y equal the rate of pump Y. Now, what we know is that the sum of these rates will give us the combined rate. So let's solve for the combined rate. To do so, we'll use a formula, rate equals work over time. Now, in this case, we're told that when they work together, it'll take 12 hours to fill the pool. So their combined rate is going to be an output of one job divided by 12 hours. Next, we're going to use the fact that the rate of pump X was double the rate of pump Y. If the rate of X is double the rate of Y, then we can substitute 2Y back in for X in the formula and arrive at the equation 2Y plus Y equals 112. Now we can simplify and we'll get 3Y equals 112. Divide both sides by 3, and we'll get Y equals 1 over 36. So now we have Y's rate. The question is asking us to determine the number of hours that Y would have to work. So now we'll use the formula time equals work divided by rate. Now the desired work here is filling one pool, so we can think of that as one job. And we know Y's rate is 1 over 36, so we arrive at the equation time equals 1 divided by 1/36. Now we'll multiply by the reciprocal, so time equals 1 times 36 over 1, and therefore the time will equal 36 hours. So again, I want to reiterate here, this question differed from the previous one in that the previous question gave us the individual rates and expected us to solve for the combined rate. This question is testing the same concept, but now we're working backwards. Here, we were given the combined rate, but we had to use that to determine their individual rates. Okay, to recap, when solving work questions, we'll use the following formulas. Rate equals work divided by time. Time equals work divided by rate. And rate times time equals work. Second, to determine the combined rate of people and machines working together, we will add up their individual rates.